Cyprian. In this tutorial, we shall be talking about the concept hybridization in chemistry. So, what is hybridization? Hybridization simply means the mixing of different atomic orbitals to form new orbitals known as hybrid orbitals that are all degenerate. What do you mean by these new hybrid orbitals are degenerate? Degenerate means that they are of the same energy level. So basically you have S, P, T, F, G on and on orbitals. So the mixing of atomic orbital, for instance, S plus P will lead to S, P, S plus P plus P will give you sp2, that's the degree of P. S plus P plus P plus P will give you sp3. So now you discover that S and P orbital, they mix, they combine together to give you an sp hybrid orbital. This is a new orbital which is known as a hybrid orbital. S plus P will give you sp2, telling you that this is a new hybrid orbital known as sp2. You have S plus P plus P plus P, the mixing of S orbital plus 3 P orbitals known as sp3 as the new hybrid orbitals. So that's just the concept of hybridization. So we'll now take a look at hybridization in methane. How hybridization in methane occurs and leads to the bond formation between carbon and 4 hydrogen atoms and leads to the tetrahedral structure of the methane molecule. It's very simple and it's very, very simple. Now, let's take a look at it. If you take a look at the electronic configuration of the carbon atom in the molecule methane, you will understand that the electronic configuration is 1s2, 2s2, and 2p2, respectively. Now, these electrons are spinning up and spinning down based on Pauli's exclusive principle, right? Now, let's now look on the hybridization. Let's see how these atomic orbitals will mix and lead to the formation of the methane molecule. So, if you look at it now, we say this is 1s with these 2 electrons. Now, these 2s now will be promoted, and by promotion, by the mixing of these atomic orbitals, they form new hybrid orbitals. Now, this will first of all split, will be promoted to the same energy level. This will now have been promoted here to have your S, because S and P will mix, right? They will have that, but I'll take it step by step so that you understand the concept. So S, you have 2S here, you have 2P now having subatomic orbitals known as Px, Py, and 2Pz. Now, once this is promoted, since it's promoted, we are not going to follow Hunt's rule because we say that all of them are now all degenerate. And since they are all degenerate, they are going to have the same energy level. And based on Hunt's rule, when filling orbitals into filling electrons into orbitals that are all degenerate, the electrons must first of all be simply what? Entered into the orbitals before pairing. So since S is now the same energy level with Px, Py, and Pz, we are now going to now promote an electron from this X to make P, forming that hybrid orbital. That is where the mixing of atomic orbitals is now occurring. Now we are going to have one electron there, one here, one here, and one here. Now, initially, 2p2 means that one electron was in Px, one electron was in Py already. But now, while these pieces have electrons that one from here has been promoted to enter into P, and since it's entering into P, it will enter into the one that is now what? Empty. So now giving you this now. Now, hypothetically, S orbital is now mixing with P orbitals. And since they are mixing, we are not going to be calling these 2S, 2Px, 2Pz. We are not going to call that. We are going to call these ones hybrid orbitals. And in these hybrid orbitals, we are going to replace them with what? Each of them will be called sp. Now, only 3 characters are here, 1, 2, 3. And since they are 3p, we are going to replace them with what? sp3, this, and this also be what? sp3, meaning that you have one s orbital mixing with 3p atomic orbitals. And as such, this is how hybridization will work. Then a bond D with 4 carbon atoms, 4 hydrogen atoms, then the hydrogen atom from here will contribute 1 electron to form a bond. The hydrogen atom will also contribute an electron to form a bond. 1 hydrogen atom here will contribute another one to form a bond. And the final hydrogen atom here will contribute to form a bond. Therefore, leading you into this sp3 hybridization of the molecule methane. So if they ask you what is the hybridization of carbon atom in methane, you're going to say that the hybridization is what? sp3. So methane is what? sp3 hybridized because 1s orbital is mixing with 3p atomic orbitals to form the sp3 hybrid orbitals. So basically, the hybrid orbitals formed here are going to be 4 sp3 hybrid orbitals. And that's it for today. Well, that is how simple this concept of hybridization is. If you want to watch more on hybridization, follow my channel on YouTube and subscribe to it, and you'll follow more tutorials on hybridization. Thank you.